Hi folks, welcome back. I hope you're all doing well. So today I want to take a look at a paper which asks the really intriguing question of whether we can crowdsource programming language design. Now, almost every programming language that we use today is designed by one person or a small number of people. But how would languages look if you just polled programmers and asked them what sorts of features and what sorts of semantics they expect in a programming language, and then designed a language that matched those expectations? That is what this paper looks at. The authors here come up with a range of questions where they have a short snippet of code and some questions about what the output of that snippet of code should be. And these questions focus on the semantics rather than the syntax. So they use some kind of syntax that's similar to existing languages but not exactly a current mainstream language. And they give these questions out to a number of people on Mechanical Turk. And then they analyze the data to find if there is any consistency, which means that people answer questions the same way, and whether there is any consensus, which means most of the people answer the questions similarly. And to give you the punchline early, what they find is that there is neither consistency nor consensus in the data that they got. So let's look at some of the questions that were asked and what programmers answered. The first question talks about scope, whether programmers interpret scope statically or dynamically. And the question is interesting because in a statically scoped language, both of these snippets of code should produce an error. If you look at this snippet, A is not defined here, nor is it defined here. And in the second snippet, D is also not defined here, nor is it defined over here. But surprisingly, the majority of the people that were polled expected some sort of dynamic scope. Now, what exactly is dynamic scope? Dynamic scope is when the value of a variable is defined not by how the text of the program looks, but by how execution control flows through the program. So in this first snippet where you're calling F first and then G, when you call F, A would be assigned 14. When you call G, A would be assigned 12 and you would print 12. So A is defined not because it's declared somewhere, but simply because the flow of execution happens to define A. And similarly, if you look at the second example, D would be defined to be 32 over here, but F calls G. So when you get to G, D is 32 and you add 3 to that and you would get 35. And if you look over here, that's what a majority of people expected this program to output. The thing is that dynamic scope is a horrible programming language design choice, and no sane language designer today would ever use dynamic scope in their language. Let's look at a few other examples. This snippet tests whether formal parameters can be accessed outside a function. The correct answer to this is that both of these snippets should produce an error, but only about 40% said so. This next example is interesting because it tests people's conception of single inheritance. So you have a class A and a class B that extends it, and then another class C which extends B. And in all of them they have this field X which has different values in each class. Now the question is down here, if you create an instance of the class C and access the member X, what value do you get? Now in a language like Java, this type would be A, and you would get X equals 3 when you print this. In a language like Python, you would get this value. You would get the value from the class C. But only a tiny fraction, basically just one person, expected these programs to follow Java semantics. There was a large cluster that expected it to produce 300, which means you interpret this variable as having the type C rather than the type A. This snippet is really interesting because Here you have a dictionary with entries for brick and house, and you're trying to look up the dictionary with the key brick plus house. Now the correct answer is that the lookup would be for the key brick house, and since brick house is not in this dictionary, this should produce an error. But they found a really interesting cluster here, which was that a number of programmers distributed this operation across the fields, which means they thought that this expression here would look up the entry for brick and then the entry for house and add them up and produce the answer 8. Here was a question that tests how programmers conceptualize floating point numbers versus idealized mathematical numbers. So what would 1 over 3 produce? And there was a large fraction of folks that thought it would produce 0.333 going on. But a very few people mentioned anything about floating point numbers. The paper has many such questions, and I encourage you to go look at it if this is the sort of thing you're curious about. But I want to get to what this means for language design. The results are somewhat surprising because very few of the answers even match semantics of existing popular programming languages. And the data does not show any consistency or consensus among the people that were polled. This means that it's really not a viable strategy to try and design a language by popularity. For example, even in the places where there was a lot of agreement, those points are not necessarily good design choices. For example, people expecting dynamic scope rather than static scope. Another example was programmers' conception of numbers, idealized numbers versus floating point numbers in computers. It was also surprising to see that nobody answered the inheritance question according to what Java's semantics are. It was also interesting to see that many programmers misunderstood object aliasing across a function call, in that if you pass an object in as a parameter to a function and then modify that parameter inside the function, you will actually be modifying the object. But many programmers expected almost a kind of call by copy semantics for this. So to conclude, what can we learn from this? So we find that programmers have a lot of difficulty agreeing on the semantics of even very commonly used features in programming languages. And in particular, some very core features like inheritance and overloading have such complex semantics that most people do not clearly understand them. So this points to two conclusions. One is that no, it's not necessarily a good idea to design a programming language by crowdsourcing. And two, that these complex semantics need to be either avoided or explained better. I hope you enjoyed that, and I will see you next time. Thank you very much.